Hello everyone. Today we're going to talk about a big topic in biology and microbiology just in general called transformation. So when we talk about transformation, we often compare it with Griffith's experiment. So I'm going to tell you who Frederick Griffith is, what transformation is, and why we use it. So a little bit about Frederick. He was born in 1879, passed away in 1941. He was a British bacteriologist. He worked a lot with bacteria pneumonia. In the experiment that we're going to talk about, he actually uses two different strands of pneumonia, and he created the transformation principle. So basically what transformation is it's a process by which exogenous genetic material may be produced into a bacterial cell. So it's basically a transformation of genes. Um, so let's move on to the experiment. So basically what Griffith did here is he did a series of 4 different experiments with mice. So the first one that he did is he had the R strain. And the R strain is the non-virulent strain. Non-virulent means that it's basically healthy, it won't kill you. So what he did was he injected that strain into the first mouse, and the mouse lived. So he was like, okay, well, let's do this next experiment. And the next one that he did is he took a different strain, um, and he called it the S strain, which is virulent. And virulent basically means that it is, um, it is dangerous. It will hurt. It's bad for you. So he injected it with that mouse, and the mouse died. And I would like to also say that the bacteria that he was using was Streptococcus pneumoniae. So both of these strands were from Streptococcus pneumoniae. When he was actually doing this experiment, which was very interesting, he actually was trying to come up with a vaccine for Streptococcus pneumonia, just in general. So he was just trying to figure out a way to cure it. So moving on back to the experiment. So I'll just start over because I know I messed you up. But first thing he did is he started with the rough strain, and that's the non-virulent strain. And he injected it with the mouse. The mouse lived. And then he took the smooth strain, which is the virulent strain, the evil one, the bad one. We don't like that one. He injected it with the mouse, and the mouse died. And so the next thing that he did, this was very interesting. What he decided to do was he took the S strain, the virulent one, and he decided to heat fix it. And when you heat fix bacteria, it basically kind of kills the bacteria. There's nothing there for it to really infect anymore. It's kind of like when we have audentation, when the bacteria turn into couch potato bugs, but this is more of a situation of the bacteria is just dead. So whenever he heat fixed it with the smooth strain, he injected it with another mouse, and the mouse actually lived. But I mean, this makes sense because we know that when we heat fix things, we kill them. So that was an experiment that we already knew was basically going to happen. So the last experiment that he did, which was his 4th experiment, the experiment that basically changed the game, was very interesting. What he did was he took the rough strain, the healthy strain, and he mixed it with the heat fixed smooth strain. And when he mixed these up, once he injected it into the mouse actually died. So this is where we get that concept of that transformation principle. So basically what happened is the rough strain, which was the healthy strain, it actually transformed into the heat fixed smooth strain. So it when they transformed together, it died. So, transformation is a concept that we use for many things now. Um, we use it to make multiple copies of DNA. We call that DNA cloning. Um, Another thing that we use it for is to make large amounts of specific proteins. For example, with humans, we use it to make insulin. So we create these large amounts of insulin to be used to treat people with type 1 diabetes. And then another thing it's used for is to genetically modify a bacterium or another cell. So to basically sum up everything that I said, um, transformation is a process where exogenous genetic material is transformed into a bacterial cell, another bacterial cell. It is a number one way of picking up genes along with conjugation and transduction. Um, Frederick Griffith was the one who created it. He created it in 1928. He created the concept while he was trying to find um, discovery of a vaccine for Streptococcus pneumonia. And so, yeah, that is it. Transformation.